Okay, so in example number 7, once again, let's try to have some more problem with quadratic-like equations. So here we want to solve for x once again. Okay, and the equation that we have this time is looking a little bit strange. How about 2x minus 7 square root of x equals 30. Now notice with this equation, sure you can, of course you can solve that using the approach that we've learned earlier about the approach with radical equation. Here we got one term, and if you can try to bring all the radical term to the right hand side and bring that non-radical term to the left hand side and square both sides and solve for it, that's going to be just fine. But here let's try to solve this one by treating it as a quadratic-like equation. So now first of all, to solve that using the quadratic-like approach, I need to subtract the 30 from both sides, and that gives me 2x minus 7 square root x minus 30 equals 0. So now, to help you recognize the quadratic-like nature in this problem, it's going to be much challenging compared to the previous examples here, because what I can see, it's hard to see the halfway, the double of the power and the halfway down, and and all that, no power here. Let me point out to you the relationship between the x and the square root of x. Okay, now what is the relationship between the x and the square root of x? The x itself is actually the square of the square root of x. That's the relationship. Okay, so now recognizing that relationship, now at this point, I have to convince you, if you're not sure about this, if my explanation here does not convince you on this, you must go back and review your square root skill right here. But once again, the x and the x with the square root, the relationship here is that the x is the square of the square root of x. And so now, recognizing that relationship, my equation here is going to turn into 2 times square root of x all squared, and minus 7 times square root of x, all that, and minus 30 equals 0. So now, at this point, recognizing here, I'm seeing clearly that we have a quadratic-like. We have a square power, no, just without the square, and no power. And so here, my substitution here is of course going to be square root of x, because I can see that here we have the repeats of the square root of x throughout the two terms right there. Okay, so here's my substitutions. T equals square root of x. So now, to solve for this problem, now after I made the substitutions, my equation turns out to be 2t squared minus 7t minus 30 equals 0. So, just like usual, we're going to switch over to solve for t, and then factoring can once again be used here, and I can see that I can factor this equation into 2t plus 5 and t minus 6. That's how you factor it. Once again, if you're not sure how I factor this, make sure you go back and review your factoring skills on this 2t squared minus 7t minus 30. Okay? The skill that's proper enough to help you through with that factoring problem. Okay. And then with this problem right here, immediately you're going to produce for yourself 2t plus 5 equals 0, and the other equations, t minus 6 equals 0. And here subtracting 5 from both sides. That gives me t equals negative 5, and dividing both sides by 2. Okay, and t equals negative 5 halves. And my other t value is going to be just simply t equals 6, as I added 6 to both sides of the equation. And once again, keep in mind, we're not done. We're not done at this point yet. Remember, the goal was to solve for x. And the equation originally appeared in terms of x. And now all of a sudden, things turn out to be, we get the answer for t. So that's not quite there yet. We're not quite there yet. Now, the link is all here. The key is all here. We need to look back at the substitution point. And now, what the substitution point is telling me is that on one hand, t equals to square root of x. But on the other hand, t equals to either one of these two values. So now, that means you can now safely set the square root of x equals negative 5 over 2, and on the other hand, as well as you can set square root of x equals 6. Okay, so now to solve for this thing, for each of these, all you have to do is square both sides and solve for x. So my x here is going to be minus 5 over 2 all square, and then x equals 6 squared. Remember, this is the proper technique how we solve square root equation that deals with square roots. So we square both sides, and after we isolate the two terms, the root term on one side and non-root term on the other side. And so my answer is here would be x equals positive 25 over 2. That's one of them. And for the other answer, x equals 36. Okay, and that's how we solve for our equation. Now, example number 8, just about a few more for you to get really comfortable. Once again, let's solve for x. But my equation here appears to be x to the negative 2 power, and then equals to x to the negative 1 plus 6. Okay, so now, before we try to recognize, even before we try to recognize the quadratic-like nature of these equations, let's just try to rearrange our terms here to the left-hand side. And keep in mind, these are negative powers, but they don't mean negative numbers, okay? So I can just simply subtract x to the negative 1 from both sides, and subtract 6 from both sides, and that gives me x to the negative 2 minus x to the negative 1 power minus 6 equals 0. And at this point, so wait a minute, so where is all that quadratic-like nature here? What I'm seeing? The negative 2 power. Isn't that negative 2 is twice as much as negative 1? Okay? Negative 2 is 2 times of negative 1. So that's, what it tells me here is I have whatever that power is, negative 1 is halfway down. And here's subtract 6. And so my equation now is clearly, now if you want to rewrite it in the more quadratic-like form, then here's what it is. The first exponent, the first x to the negative 2 power, you can write it as x to the negative 1, and you square that again. And minus x to the negative 1 power, okay, and minus 6 equals 0. Okay, so now it's looking at all trivial that here's we have the repeat of x to the negative 1, and that is going to be acting as my substitution again. So t equals x to the negative 1 power is my substitution point. So now, what I'm having here, so back into the equation, I can replace the t for the x to the negative 1 power, and I have t squared minus t minus 6 equals 0. And then factoring this equations to solve for t at this point, we need to split directions a little bit. We need to switch directions a little bit. So I have t minus 3 and t plus 2. That's how we found a factor for this equation. So now that immediately produced x minus 3 equals 0. T minus 3 equals 0 and t plus 2 equals 0. And that gives me 1t by equals 3, the other t by equals negative 2. Okay? And now, back to solve this. If you compare that back to the substitution point, which is still here on the screen, okay, what I'm seeing here is that I can set x to the negative 1 equals 3. And at the same time, I can also set x to the negative 1 equals to negative 2. Okay? But now, what does that mean by x to the negative 1? Now, keep in mind, x to the negative 1 means we have 1 over x equals 3. That's the nature of x to the negative 1. So x to the negative 1 is the same as 1 over x. So here we have 1 over x equals negative 2. So now to solve for x, all you have to do is take the reciprocal on the two sides. So that means we have, taking the reciprocal on the left hand side, I have x equals, now here it's 3 over 1, so taking the reciprocal, it's going to be 1/3. So x equals 1/3. On the other equations, taking the reciprocal from two sides, x equals negative 1 over 2. And that's how I end up with the two solutions of the equation.